We're going to go ahead and we're going to talk a little bit. I want you all to take a nerd adventure with me. And I need your permission because this is going to be a story. You've learned so many interesting facts. You've learned about principles. But one of the things I think that makes this most tangible is when you see something and you've actually experienced it. And so I want to give you an experience that I think that's very fun, interesting, touches a bunch of different aspects that I had to go down a rabbit hole for a while. And this whole idea is the fear that a lot of us have. How many of you have done things in 3D, like 3D transforms, 3D applications, had to take a 3D graphics class to use Unity and things like that? You know that math gets pretty damn scary pretty fast, right? And how many of you have taken like calculus and multiple like sciences and stuff like that? Yeah. And there's something amazing about that experience, right? But you don't feel like you get to apply it when you're building products for other people. And so I'm here to give you this story. I want to bring you along with me on a journey into the world of feeling a need, going into mathematics, and coming back out alive. So the idea here, I am Gant Laborde. I've been a software developer for 20 plus years, and I own a wonderful company called Infinite Red. I have talked here before. I talked about AI. I speak a lot about AI. As a matter of fact, I've written a book in O'Reilly Press called Learning TensorFlow.js. So if you are interested in talking about AI, let's talk about that. Also, I love mobile apps. If you want to talk about mobile apps, let's talk about that. But today, like I said, we're going to get started. We're going to talk a little bit about math. Okay, so I'm sure this is rudimentary. We're going to start here. No, I'm just kidding. That is not what I'm going to do to any of you. Sort of. Here's what we're going to do. I know math sucks, right? At some degree, we either get to use the hell out of it and it feels amazing, or some degree we don't. But it does feel really difficult when you go into that world alone. The math teacher is booing, of course. So, what if I told you math can make things even easier? Just understanding these principles will help you in the future. So one of the things that I like is I want to bring that real world example. And like I said, I want you all to nerd out with me here today. That's why I'm going to have lots of Star Wars references, and because I'm a weirdo, I'm going to have lots of other nerdy references, okay? So I need you to go ahead and you need to see an example of how this came into a project from one of our clients and how they actually came in and said what they needed. They said they want phones to scan documents and just be able to see it. And you know that everybody knows this feature, right? You've all gone and got your checks, and then you sign them, and then you point your phone at them, and then it goes ahead and it scans the amount, and then tells you how much it is. So that was a check for $5,000. They scan the front and the back, and then what they want to do is they go ahead and enter $500 because they're idiots. And then what they do is that goes into their bank account. And what we really want to have here is we want to have that feature, but for everything, right? The client came to us and said, I want people to scan their insurance cards. And so that's no problem. That shouldn't be too hard. So let's get that insurance information. This turned into what that client paid for was about a month of mathematical discovery. So we did this initial reference here, and here's my Barnes & Noble card. And what you're seeing right there is how most people can sometimes scan things. They scan it at this ridiculous angle. And if you throw that into an OCR, like the online OCR for object character recognition to pick out the text, there's a key part here that you need to notice. It couldn't read the card. So not only were we having trouble with the card, getting it all perceived, getting it set in there, it didn't read any of the text from that weird angle that we saw a second ago. So we went into an experiment here where I could take a picture. And how many of you have used Photoshop before? Photoshop users? Yeah? Yeah, nice. And so what's funny is, like I say, here's what I want the card to be like. You know that you can use this transform tool. And once you use the transform tool, you can actually take something and then shore it up and almost like correct it in a weird 3D space. So here's what I'm doing in Photoshop. I've taken the card, resizing it. I'm just pulling each of the corners to their respective corners. So you can see I'm getting it set there. And the card's becoming more and more like it was actually just facing the user, right? And so once you pull this enough, you set up and you've warped the card a certain way, you get before and after And what happens when I take that same exact image and I feed it into there? Look at that. All the text comes through. So that's it. All we need for the client is every time somebody takes a picture of their insurance card, you just need some dude with Photoshop to sit there, open it up, and then just transform it. Like, this is a great solution. I don't see how it could possibly fail. Well, the truth is, we're all engineers, and we all are trying to solve these problems. And we have all these wonderful solutions at our base. And I promise you, this is one of the weirdest things, because I've seen all the technology in this before, but I just didn't know what to do. So how do we warp stuff? What tools do we have to do this? And why is linear algebra here? Is this an intervention? So I have a goal here. What I would like to do is give you a choice, right? You have this moment where you can just be like, this is someone else's problem, or I can get a library to do it. But what happened is there was just no library, so you have to go actually figure out what the hell all those things are. And so how do you do that? And by the way, I'm way too proud of this joke. We have to get a little bit used to 3D, and then we have to, watch this. Yeah, you're back in grade school, and I'm sending you codes. You have to get some perspective. Oh, isn't that cool? That makes sense. That's why I had the words flying off on the other side, because this is all the same trick. So I want to show you some 3D vocabulary. I want to familiarize some concepts, and I want to embrace the 4x4 matrix. How many of you have used matrix transform 3D CSS property and seen the 4x4 matrix? Yes? Have you wondered why the hell it's a 4x4 matrix? I'm going to answer it. All right, so add your vocabulary. Starting in 2D, we have this classic thing. So we have this, we have the screen coordinate system. Now, we all know what the Cartesian coordinate system is. That's like classic X and Y, but it has the Y inverted. Thank you, Maverick. And then what happens here is that we still are in a Cartesian coordinate system. So if somebody's saying, like, what is the coordinates there? It's commonly referred to as the screen coordinate system. If you have other words for it, please let me know. I've heard it called a bunch of different things. But the screen coordinate system seems to be the correct way, where the Z actually counts going to down, or actually the Y is inverted, so it counts, and that's 0, 0 at the top left of your screen. Now, is that Z pointing in or out? The Unity people will start screaming right now if I actually answer that. So what is Z in the 2D world? Well, here's another cool word for you I learned: orthographic projection. Ortho means true, graphic means write or draw. Orthographic projection is what we all like to use in all of our apps. All of our 2D apps emulate the stacking style using orthographic projection. And so what this is it means to draw it as it truly is without any distortion. If you are big, how many of you went and saw the eclipse and were outside like, yeah, it's freaking cool. All right, my nerds are here. I'm happy about this. But you can actually see that in this example, I'm able to eclipse the red ball with the white ball and the white ball with the red ball, and they're exactly the same size. So this is kind of how we treat orthographic projection. If you had two elements instead of a Vue app and they're exactly the same size, it just depends on which one you put on top. And we use this in the painter's algorithm to draw structures and apps and scenes. You draw from the furthest thing to the closest thing. That's your Z-axis. Remember your Z-index. That's what you're saying. So as you're drawing, you're just getting closer and closer and closer to the screen. But what you're actually doing is you draw the furthest things first and the closest things next, and it lines up that the painter's algorithm puts those on top. So you care about that, especially when you're doing parallax. Another thing is perspective projection. This is what I'm going to talk about. This is where warping comes in. This is when something is closer, it actually seems bigger. This is the world we live in. And honestly, I'm going to argue right now that this is going to be what we're going to see a lot more of in thinking in 3D as the VR world continues to take off. So what you have with that is, depending on how far away or close it is, it's actually divided by the distance. You simply divide by Z, and what that does is it actually creates the sides to be different. Even though that's the same exact size on the card, A is actually bigger than B because it is closer to the camera. And have any of you ever coded a star field like this? It's ridiculously easy to code. I highly recommend that you do it, because all you're doing is you're assigning what the distance of it is, and you divide by that distance. You divide by that Z, and what that will do, as it gets closer, you can have it get bigger because it's dividing by the different number. And what happens is it also goes faster because you just give it the X and Y coordinates, and then change the distance a little bit closer, a little bit closer, a little bit closer. I should give you the code for this. This is actually really easy to do and kind of fun. So 3D cares about Z, right? This is perspective. This is orthogonal. So we have to get in here just to have a little bit more fun. 3D feels cooler, just like a little bit of, not that 3D needed me to come here and tell you how cool it is, but CSS properties, it feels more natural. It's a neater thing to do it. And like I said, I think it feels like what the future is probably going to be. So I say this talk's probably going to get more and more attention as you go further. 3D is going to be the superpowers along with AI. So, all right, math, how do we do this? So what we need to do is we need another familiar concept here to learn the ways of the force, is that how math does this. And what it does is it has linear transformations. Linear transformations could do some stuff that help you move graphics around. Thanks to mathematics using linear transformations, we can move all these points around, we can shear them, we can rotate them, we just can't change their point of origin. This is a video from 3 Blue, 1 Brown. I don't know if y'all are fans of that YouTube channel, but yes, indeed, it is fantastic. So with that, we can rotate, scale, and shear. So we can do all the things, 3Ds, 3 transforms, but what about moving? And this is, I promise y'all, this is probably the nerdiest damn part of my entire presentation. This is super cool. How do you translate an object in 3D space? How do you move it? And the answer is, we're ready? How you do that? You can't. You can't. So what the hell is going on? How are they able to do it? And this is where the crazy ass riddle of why we have a 4x4 matrix. It's not rocket surgery, so computer graphics can do this. It's a simple math hack. This is so cool, y'all. This is gonna blow your minds. I think we're gonna enjoy ourselves. If you followed the nerd journey this far, get ready, strap in, okay? So, we use shearing, which is totally allowed because it doesn't change the origin, to translate in space. I'm going to show you how to do this from 2D to 3D. Watch this. We have a 2D space. We want to translate it over, but we can't because that would change the origin. Well, what if I add a dimension? I bring it into this third dimension, and then I shear that dimension. I shear it. And then I project it right back down to a 2D space. I ignore that dimension that I added. And now my linear transforms, all those GPUs, all those fantastic linear algebra algorithms suddenly work back to translate things that you can move them through space. That's the damn answer on why we're constantly handed 4x4 matrices. Okay, I feel like I'm starting to learn something. Is the client still paying? Okay, we're good. So that seems like a lot. Let's go ahead. We're empowered now. We can do anything we want, right? We can rotate, translate, shear. We can do stuff to an image of a card so that we can go ahead and make it fit. Well, now it comes all down to that matrix I was talking about. And I know what you're saying, Gant, you've used a lot of Star Wars algorithms. Why are we all of a sudden talking about the matrix now? Are you going to start talking about the matrix? Yes, because I'm a nerd and y'all going with me. Too bad. Let's do this. The 4x4 matrix, right? Embracing that. So a matrix, I'm going to give y'all the worst example. Where's Ken? He's going to be mad at me. He teaches math. So here's what happens. Why do we have matrices? Why is that data grouped together? Because you care about the parameters, but we also really care about the order. So if I care that if I have an X and a Y, I can't swap those numbers around. We know this in coding. In arrays, the order usually or sometimes can matter, right? So we can't just put the 5 where the 3 was and just say, hey, they're all in this bag. So you have particular positions. And when they started writing 3s and 5s, they started writing these numbers together, they're like, well, I have to say that this order is actually important. And that's why they actually write it like this. You've seen this in vector math. They write it up and down to indicate that it's not just us writing something. This set that I'm giving you inside these braces has a specific order that is actually important. So with these matrices, when you can, how big do you need for that? We've already covered that, right? It's what? Thank you. I love the mumbling nerds. That's my favorite part. 4 by 4, yes. All right, so we're set. So we got this. We're going to read the columns. You know how to read a matrix, or maybe you don't. Doesn't matter. You don't have to do this part. But so we have that set up there. Multiplying matrices applies the transform. So as long as we have this set, we can actually apply it. With a 4 by 4 matrix, we can apply all the different transforms that we need to a particular space. And in all computer graphics, we get that space. So all it does is it takes all the points that exist and then multiplies them against your little happy 4 by 4 matrix, and then the results are what you get. And we see this with the matrix for 3D transforms. So, okay, so where do these go? It goes right into CSS. Okay? I wish I could say that there's some really cool 3D graphics that we're going to code here. We're going to do a Vue app, but it's the actuality of it is that you're just going to compute, if you want to animate it, it's going to compute the matrix 3D transform property. And that's it. You can put it in there and you can see it right away. That means if you can go from this to this, all you have to do is know what linear transform to multiply it by. You don't have to do a bunch of steps. It's one multiplication to go from that to that. Okay, we're getting along here. This is going pretty well. So, by the way, I told them I have the follow the white rabbit in my presentation, so they gave me the sticker here as well. But let's go ahead and take a look at this one last piece. So now we just got to figure out what? We need to figure out how this 3D transforms look. So I want to show you this. All I'm doing here is I'm applying a matrix 3D transform. Can everybody see this? Cool. So if I change these numbers right here to say like the scale x, I move this to a 10, then you can see that the x is being transformed to be 10 times larger than it was. If I go ahead and I change the y on this matrix, and by the way, this is called the identity matrix with those ones across the diagonal. My nerds are totally remembering this stuff. Identity matrix! Worked perfect, yeah. So I move this to a 10. I'm doing that by y. I can shear along the x-axis by moving this to like, let's move this to 10. Oh, that's a w, so that's not going to work. Perfect. And then here's my favorite thing here, over here, because it's in the 4th dimension. Let's translate x by 10 pixels or 100 pixels. And I can move it over here. So all I'm able to do is I can do all those cool mathematical functions, and I don't have to do anything magical. All I have to do is set this 4 by 4 matrix and set the transform for the matrix 3D in the CSS property. So this is how all those cool animations I was showing you before with things flipping and moving and animating, all these other different places, they're just playing with this. And so if you want to go ahead and you want to add some kind of extra dimension, but you want it to feel as a perspective rather than orthographic, you can go ahead and modify the 4 by 4 matrix that you're passing to it and then get all kinds of cool properties out of it. So now all we have to worry about is going to the next slide, which is actually a lot harder when you start interacting. Okay, so what is that matrix that we're multiplying by? That's all we need to get now. Well, this is where it's going to get really nerdy, really fast. And I apologize, just stick along with me on this one because I had to do all this crap. And it's super fun stuff, but I want you to appreciate like what's actually going on there. And I'm going to make it in a way that I think that's completely understandable that you could bring back to your own clients. So you have the corners, the 4 points that you want to go ahead and use, and then you want to move it and normalize it to another space. So what that means is if you have a graphic and you knew the 4 by 4 matrix, you could go ahead and make that text face the camera so that way it's just the only part that you have. So that means that there's actually, because we don't care about the z-axis when we're done, we're looking at a 3 by 3 matrix that'll come out to the end of this that'll make it work, because actually we don't not worry about translating either. But the z is getting thrown away. So that means that A, which is your image, times H, which is the matrix, equals the one that we want. And what we want to do is we want to figure out what H is. So where's my algebra people, right? We want to go ahead and do some algebra. Ken, stop cheering. So we need to go ahead, we need to move A to the other side. But in algebra, you would normally divide both sides by a, right? But you can't divide both sides by a, right? So we're going to hit each side with a inverse. He's so happy, y'all. Can we stop this? Where were you when I needed this information? So we're going to go ahead and hit both sides by a inverse. That'll turn the left side into the identity times h, and the right side to a inverse times where we want it to be. And that's it. That's it. That's how it's going to get there. We can figure out what h is if we know what the image going in is, and we know where we want that image to be and what we want it to look like. So with that, we can go ahead and we can move this to the other one. Y'all want to see CSS do this? Yeah. All right, let's see. Believe me or not, let's see a demo. Okie dokie. So here's a terrible app that I wrote. And what we're going to do is we're going to tell it where the corners are. So I'm going to pull down on this side. And I'm going to say down here, log the first edge, which is going to give us 2 points. And I'm going to say, come over here and give me this side. I think I wrote this in regular HTML because I was just lazy. And then here. All right, now ready? I'm going to hit the process button. Let's see. 3, 2, 1. Hey! There it is! Thank you. I love it. And then you see down here at the bottom, that is it just not cropped. That is the image with just the CSS. And then just to be for fun, I can give you all the access to this code. We'll go for like another image here. We'll grab this one real quick. If it breaks now, I expect you all to boo. By the way, it's really fun to not grab the actual edges and just send this thing into the stratosphere. So hopefully I click the buttons right. Grab this edge to this edge. So that's my 4 corners. I know where I really want to go. Record. And then process that. Boom, there's another one. Yeah! Almost as exciting the second time. Okay. So here we go. So that was a really amazing moment for this whole thing. Like going into the linear algebra, bringing it back, going to the client, and say like, well, dude, did this end? How's the story end for you? Like, did you go to the client? Did they pay for all that stuff? Did they like it? Dude, well, check this out. Like, you can see how this stuff works. I can give you all the access to the code. You can just ask Ken all about the math. But I wanted you today to understand the 3D vocabulary, familiarize the concepts, and embrace the fact that it's a 4x4 matrix, and I finally understand why. And then you've gone through this nerdy adventure with me, and I really appreciate all of you to do that. So the final product, here it is. Like, we actually had it. We delivered it to the client, and there was an API built into the phone that detects rectangles. So I already could like detect something on the surface. But if you look here, let's see. All right, we're moving it around like crazy just to piss it off. There's the rectangle. And then boom, there it is. Hi, Gant. And then it errors because there's no insurance information on that card. So it doesn't make any sense. But yeah, then we got that set up. Was the client happy? Absolutely, yes, they were. But I couldn't get them an image of that. So I just asked AI to generate a very happy client who got some really cool nerdy-ass 4x4 matrices that were inside their app. This is just a lot of fun, cool stuff that kind of goes in there. And it's just sitting there the whole time. But I think like that's what's really great about this, right? We're all sitting through these crazy adventures individually and together, and we all have these really crazy little stories of how we've dug deeper into math, we dug deeper into these problems, and then we came out a little bit wiser and a little bit better. So I do ask that if you have some of those stories, please tell me them. I love that you shared this one with me, but I would love to go ahead and hear the ones that you have. So let's go ahead and let's have a drink in about 15 minutes at the bar, and then we'll get that set up. So now it's time for A New Hope. Where to go from here? Dude, if you thought this was cool, this guy is amazing. You want to go to pikuma.com. This dude's in London. We had coffee together. His courses on building 3D code from scratch. You can build your own Nintendo emulator. You can do all this stuff. This dude's the OG of how this all actually works. And then also, you see matrices in action. Matrices are very popular in machine learning. I have a book. I didn't bring it today because I didn't know I was going to be talking today. I thought I was talking tomorrow. But tomorrow, I'll have a couple of copies of my book. If you can catch me before I hand them off to anybody else, I'll happily assign it. It's Learning TensorFlow.js with Gant Laborde. And then also, if you ever need a mobile app, my fantastic company, most of the time comes up with mathematical solutions way faster. And we are Infinite Red. Thank you so much for joining me on this journey. And hit me up at hitmeup.ai/Gantt. Appreciate it.